Welcome to another deep dive. Today, we're going to be exploring something.
Oh, cool.
Yeah, it's pretty mind-bending, actually, the connection between logic and time.
Okay.
Buckle up,
Right.
because we're about to unpack a fascinating conversation with an AI
Oh, wow.
named Claude
Yeah.
about how our understanding of time might be influencing our very systems of reasoning.
Huh. So, like, the way we think.
Yeah, exactly.
We often think of logic as this universal, unchanging system, right?
Right.
But what's so intriguing is that it actually rests on a few fundamental assumptions.
Okay.
And these assumptions themselves can't be proven by logic alone.
It's like trying to build a house without a foundation. So what are these mysterious, quote, pre-logical assumptions that Claude talks about?
Well, there are 5 key ones,
Mm-hmm.
and we'll get to all of them. But let's start with the most famous one, the law of non-contradiction.
Okay.
It states that something can't be both true and false at the same time and in the same way.
Yeah.
This might seem obvious, but how do you actually prove it?
It feels like trying to prove the sky is blue. Just IS.
Right.
But this seemingly simple law leads to all sorts of deep philosophical questions. And here's where it gets really interesting. Claude argues that even this basic law hints at the importance of time in logic.
Oh, interesting.
Yes.
Think about it. The law of non-contradiction itself
Mm-hmm.
uses temporal language.
Yeah.
At the same time,
Mm.
it suggests that time might be more fundamental to logic than we realize.
So could a being outside of time, imagine God to be, even use logic as we know it?
That's a wild thought.
Right.
It certainly challenges our assumptions.
Yeah.
And to illustrate this idea further, Claude uses a really compelling analogy, the flatlander.
Okay.
Imagine a being that lives in a two-dimensional world.
Okay.
If we as 3D beings were to pass through their world, they would only experience us as a series of 2D slices, changing over time.
That's a fantastic visual. So Claude's point is that we might be like the Flatlanders. When it comes to 4D spacetime, we're experiencing this vast, multidimensional reality as slices through time, which could be limiting our understanding of logic.
Precisely. Our if A, then B logic
Mhm.
might just be a simplified way of looking at relationships
Mm.
in this larger 4D reality, just like the Flatlander can't grasp the full complexity of a 3D object from its 2D slices. We might be missing a deeper understanding of logical relationships because of our limited temporal perspective.
So what would a logic system that truly incorporates time look like?
Yeah, that's a great question.
Because Claude actually goes on to suggest some really mind-bending ideas.
It does, yeah.
Yeah.
Right. Instead of thinking about truth as a static, true or false,
Mm-hmm.
Claude imagines truth, world lines that weave through space-time.
Mm.
This suggests that truth isn't fixed,
Mm-hmm.
but rather evolves and changes over time.
So truth values would be more like
The rate.
dynamic patterns
Right.
across all of space-time, not just a simple on-off switch.
Exactly.
That's incredible.
It is. And instead of seeing causation as a simple A then B sequence, it could be understood as geometric relationships in this 4D reality. Imagine causation not as a chain of events, but as a complex web of interconnectedness across space-time.
Wow. It's like our current logic is just a shadow play on the wall of a cave compared to this.
Yeah.
But if our concept of time is so crucial to logic, what happens when we start messing with our understanding of time itself? Like, think about Einstein's theory of relativity.
Ah, yes. Relativity shows us that time isn't absolute, but can be warped by gravity and motion.
Right?
Different observers can disagree on the order of events, depending on their relative motion, which throws a real wrench into our simple notion of true then false, playing out in a neat sequence.
Exactly. So maybe our logic needs a relativistic upgrade too.
Perhaps a logic that acknowledges the fluidity and interconnectedness of space-time could help us make sense of some of the biggest mysteries in physics, like quantum entanglement.
Right. Speaking of entanglement, you know how we were talking about how understanding it might require breaking free from our current understanding of time.
Yeah.
Well, there's this wild idea in the source material. What if, with entanglement, the conclusion actually comes first?
Oh,
Yeah.
it's almost like the universe already knows the outcome, and the process we observe is just a way of arriving
Okay.
at that predetermined conclusion.
Okay, that's definitely going to need some unpacking. But first, let's take a closer look at Claude's other pre-logical assumptions, because this rabbit hole goes even deeper.
Yeah, let's dive back in. We've got 4 more assumptions to explore, each with its own mind-boggling implications when viewed through the lens of time. Welcome back.
I don't know about percolate. My brain feels more like it's gone through a blender. But you're right, we've got more to unpack. Before the break, we were starting to explore how this idea of the conclusion coming first could potentially shed light on some of the biggest mysteries in physics, like quantum entanglement and even the measurement problem.
The measurement problem, if you recall, arises from the strange fact that in quantum mechanics, observing a system seems to force it to choose a specific state out of many possibilities.
It's like our consciousness is somehow influencing reality itself.
Yeah, it's always felt kind of spooky to me.
But if we look at it from this conclusion first perspective, maybe it's not so strange after all.
Exactly. If the conclusion is already set, our act of observing doesn't change reality. It just reveals the predetermined outcome. It's like the universe is solving a puzzle, and the measurement is simply uncovering the final piece.
So instead of thinking about it as collapsing a wave function, it's more like the wave function was always going to collapse to that specific outcome. It's just that from our time-bound perspective, it looks like our observation is doing the collapsing.
Precisely. Our linear cause and effect thinking makes it seem mysterious, but from a broader perspective, it might be perfectly natural.
Okay, that actually makes a lot of sense. And how does this conclusion first idea apply to quantum entanglement? Because that's another one that really messes with our intuition about time and space.
Right, entanglement. That spooky action at a distance Einstein talked about is where two particles are linked in such a way that they influence each other instantly, regardless of distance.
It feels like they're communicating faster than anything should be able to.
It seems to violate the speed limit of the universe, the speed of light.
But if we entertain this conclusion first logic,
Then those entangled particles aren't really communicating across space at all. They're just two parts of a single unified event in space-time. The spooky action only appears spooky because we're trying to impose our linear time-bound logic onto a reality that operates on a fundamentally different level.
so in 4D space-time, it's not two separate things happening. It's one event, just perceived by us as separated by time.
Exactly. It challenges us to expand our understanding of causality and consider the possibility that what we perceive as cause and effect might be more like two sides of the same coin, inextricably linked across space-time.
Okay, that's mind-blowing. But I'm starting to see how this new way of thinking about logic could open up all sorts of possibilities. But if we take this idea to its extreme, does it mean that free will is just an illusion? That everything is predetermined?
That's the big question, isn't it? And it's one that philosophers have been wrestling with for centuries. If the conclusion comes first, does that mean we're just along for the ride?
It would certainly turn our whole legal system upside down if we couldn't hold people accountable for their actions.
It certainly raises a lot of questions.
Yeah.
But let's not jump to conclusions. Even if our choices are predetermined in some grand cosmic sense, does that necessarily negate their meaning or significance?
That's a good point. Just because a movie has a set ending doesn't mean the story isn't engaging. We still experience the emotions, the twists and turns, even if we know how it all ends.
Precisely. It might even make the journey more meaningful, knowing that we're all playing a part in a grand cosmic narrative.
And speaking of narratives, let's get back to the 5 assumptions Claude laid out for us. We spent a lot of time on the law of non-contradiction, but there are 4 more to explore.
You're right. Let's circle back. The next one on the list is the law of identity, which basically states that things are what they are. A cat is a cat, a rock is a rock. Seems pretty simple, right?
Yeah, that one almost feels too basic to even think about.
But think about this. Our very concept of identity is tied to our perception of time. If time isn't this linear, absolute thing we often assume it to be, what does it even mean for something to be itself over time? Does a river stay the same river even though the water is constantly changing?
Whoa, that's a really good point. It gets really tricky when you start to question the stability of identity over time. What constitutes a thing that remains itself? Is it the atoms, the information, the constant process of change?
Exactly. These are questions that philosophers have pondered for ages.
Yeah.
And the connection to time makes them even more fascinating.
Okay, on to assumption number 3, the law of excluded middle. This one says that any proposition is either true or false, no in between.
This is another cornerstone of classical logic. But again, things get interesting when we bring in the quantum world. Quantum systems can exist in a state of superposition, where they're both possibilities at the same time until they're measured.
It's like that famous thought experiment, Schrodinger's cat. The cat is both alive and dead until we open the box and observe it.
Exactly. So if reality itself can exist in these blurry states of potentiality, maybe our logic needs to evolve to accommodate that. Maybe instead of a strict true or false, We need a logic that allows for shades of gray, for probabilities and possibilities existing simultaneously.
So the law of excluded middle might not be so middle excluding after all. Okay, what about the next assumption?
The next one is the reliability of human reason. We assume that our minds can accurately perceive and process logical relationships.
But we all know how often our emotions, biases, and past experiences can cloud our judgment.
Precisely. Cognitive science is revealing all sorts of limitations in human thinking. We're prone to errors, shortcuts, and all sorts of mental biases that can distort our reasoning.
So even if there is some perfect objective logic out there, can we flawed humans even grasp it?
That's a humbling thought. It also raises the question of how much of our reasoning ability is hardwired into our brains, and how much is shaped by our environment and experiences.
The old nature versus nurture debate. Okay, one last assumption to go. What's number 5?
The final one is the uniformity of nature. This assumes that the universe operates according to consistent, knowable laws, which allows us to make predictions and build scientific models.
But what if those laws aren't as fixed and unchanging as we think? I mean, we have chaos theory showing how tiny variations can lead to drastically different outcomes.
And quantum mechanics has shown us that. Randomness and uncertainty are fundamental to reality at the smallest scales.
So maybe instead of searching for these grand universal laws, we need to embrace a more nuanced, probabilistic view of the universe.
A view that acknowledges the interplay of order and chaos, predictability and surprise. A view that maybe aligns more closely with how the universe actually works, rather than how we'd like it to work.
This deep dive has really stretched my brain. We've gone from the seemingly simple rules of logic to the very nature of time, reality, free will, and even the limitations of our own minds.
It's been quite a journey. But remember, this is just the beginning. There are so many more questions to explore, so many more layers to peel back.
Welcome back to the deep dive. We've been on quite a journey today.
It has been a deep dive, hasn't it?
Yeah, exploring this fascinating and sometimes mind-boggling connection between logic and time.
We've challenged assumptions, confronted paradoxes, maybe even glimpsed a new way of understanding the universe.
I feel like I need a bigger brain after all this. But it's so exciting to consider the possibilities that open up when we start questioning the foundations of logic itself.
Exactly. And that's really what this deep dive has been all about, encouraging you to think critically, to challenge your assumptions, and to explore new ways of seeing the world.
We started by looking at those 5 pre-logical assumptions that Claude laid out, our AI friend, as the foundation for all logical thought. And we saw how each of these assumptions, from the law of non-contradiction to the uniformity of nature, can be profoundly impacted by how we understand time.
If time isn't this absolute linear thing we often assume it to be, then our very concepts of truth, identity, causality, even the laws of physics, might need a serious rethink.
It's like we've been wearing these time-tinted glasses our whole lives, and now we're finally taking them off and seeing the world in a whole new light.
And this new perspective might just hold the key to solving some of the biggest mysteries facing science and philosophy today.
Like quantum entanglement, the measurement problem, even the nature of consciousness and free will. These are all puzzles that have stumped some of the greatest minds in history. But maybe a new understanding of logic, one that incorporates the fluidity and interconnectedness of space-time, could provide some answers.
Or at the very least, it could lead us to ask better questions.
So as we wrap up this deep dive, let's leave our listeners with a final thought-provoking question to ponder.
If we could step outside of our limited time-bound perspective, what would the universe look like? What new insights into logic, reality, and even ourselves might we uncover?
We encourage you to keep exploring, keep questioning, keep diving deep into the mysteries of the cosmos, because the most important journey is often the one we take within our own minds.
Thanks for joining us on this incredible adventure. We'll see you next time for another deep dive into the unknown.